Assalamualaikum and a very good day. My name is Adzlan bin Suwarto, ID number 20114, and today I'm going to present my lab 8 work. And my group is only me and me alone. And I'll start. So the first thing that we need to do for the lab number 8 is to import the required library. For example, in this one, I import two main libraries that much needed in this case, which is pandas, and I create a variable named as PD, and then numpy as NP, which is usually used for the maths, and pandas is used for the datasets. And next is to get the CSV files from the link provided, and then this one is I import a library, not also a library. I import a library, sklearn datasets, and import the load iris, which is to load the datasets that I've chose, which is the iris datasets. And then next is the import required library. It's the same, it's repetitions, just to make sure. And then now, after I import, we have to load the iris to make sure that we get to see the iris dataset and we imported a right datasets. That's the main reason why we need to load. So here we load the iris, we declare a variables named as iris, and then we create a data frames that consists of the data iris.data, and then which the column iris.feature names, and then we also set the species column as the iris.target in this case. And then to make sure that we imported the right datasets, we print a df.head to print the column. So we can see here, this is the first 5 of the column. If you print a df.head, it will print the first 5 rows of your datasets, and if you print the df.tail, it will print the last 5 column of your datasets, row of datasets. Next is to make sure to get the data types of our data frame just now, just to make sure it's all in the numbers format, float or integer or doubles, it doesn't matter. Just make sure it's in the number format, because if it's in the string or the object format, it will be harder for the modeling to make predictions. And the next is to get the dataset of view, just to get the informations, which is this one, is to get the numbers of rows, and you can see here the length of the df, and then the numbers of the columns, df the columns. As we can find here, the number of rows of our dataset is 150, and the column is 5. And next, we need to know each information of our features data, which is excluding the target, which is the species. So we have 4, which is the sepal length, sepal width, petal length, and petal width, which is all in cm. So we need to find the information about the value. So in order to that, we need to create a visualizations. In this case, we have to import the matplotlib.pylot as plt, which is to create any plot or chart in Python. And next, to get a figure size, and then this one is the repetitive, which is the loop to print every information for all the column, which is in this case the sepal length, sepal width, and it will keep repeating until it reaches the target. So in this case, yeah, this is the column, the bins, and then the edge color, just to make it differentiate, and then the color of the bar, which is I set it to the pink. And next is, of course, we need to put a title so that the end users will more understand about the visualization and they will not just confuse. As I put MPLT show just to show the type. This is the graph that I've been displayed. As we can see, the sepal length, the most value that we can find is on the 5 cm mark, and then here the sepal width is we can find at 3 cm, and for the petal length it's between 1 and 2 cm, and the petal width is between 0.0 and 0.5. And next, I want to find the correlations between the value, the features in the datasets. We have 4 features in total: sepal length, sepal width, petal length, and of course our target, the species. So in order, we need to find the correlations, because correlation is very important to find the relationship between the variables, because sometimes this variable doesn't have any strong relationship with this one, which will make it difficult when doing a prediction modeling later. So we will make it prediction modeling process easier. We have to make sure that we have to find the best correlations for the map. And of course, the first things we have to do is import the required library, and the next we straight into the calculate the correlation metric. As we can see, the variable here, and then the f core is to find the correlation metrics. And then here I set the heat map gradient. I choose a visualization heat map to make it easier to find the correlations, to visualize the differences in the relationship between gradient. And then this one is to just the format of the heat map. And then here is the loop to get the top 3 correlation variable pairs, because this is important to find the top 3, because for the end user, it is not important for them the one is correlated the most. They want to find the variables that are correlated the most, which is this one is very important to find the top 3 correlated variables. Next is to sort the correlations value and select the top 3, just the top 3 just now. And then last but not least is to print, and here's the result. You can see here the correlations between this one is all the variables here and also the variables here. This is the heat map kind of format, so it will be easier for me to visualize what is correlated the most and what is not. And for the result is here, the topic correlated variable pairs is petal width and petal length with 0.96 cms, and also species and with each of the petal. You can see here the petal, of course, with the same variable from the petal width and petal length has the same. It's a very large correlated. And then next is to set the features. We are moving to the prediction modeling phase, which is to set our x variables, which is the independent variable, and independent variables. So in this case, I first create a feature df to remove the target, which is the species. So I create a new df which includes sepal length, sepal width, petal length, and petal width. And then next, I create an x array for independent variables, all column except target, which is x. Here, the feature df I already create just now. And then next is I create our target, which is y. And then next, to measure, check the x shape and y shape. X shape, of course, we have 150 rows and 4 columns. And for the y shapes, we only want 150 rows but no columns, because since it's already have 1 column in it. Next process is to find the best modeling classifier out there. So in this case, I compare them based on the evaluation metrics, which 4 main features, which is the accuracy, precision, recalls, and F1 score. So the first thing that we have to do to compare the model, to find the performance metrics, we need to import all the necessary library, which is the first one is to trend test, second one is to sklearn, and for sklearn metrics, which is the accuracy, precision, recall that I mentioned before, and then all the classifying model that we want to compare. In this case, I have 7 classifying models. And then the next step is to split the datasets into X trend, X test, Y trend, Y test. But it doesn't matter to trend test data split. It doesn't matter with what ratio which you use. In my case, I use a 30%, 70, 30% ratio. This one is to be corrected. 70 operations, and the random set that I put as 1. And then next is to initialize the classifier models to make sure I set the variable for decision tree as decision tree, so it makes it easier for the model to predict and to compare different model. And then this one is to initialize the list to store the performance metrics. This may not be useful now, but it will be useful during a visualization part. And the next is for the loop, which is to train and evaluate each classifier. So for this code, within the loop, each classifier is trained using the fit method on the training data, xtrain and ytrain, and after training, the trained classifier is then used to predict the labels of the test data, which is the xtest, using the predict method. And the predicted labels are stored in the variable ypred. And then next, to evaluate the classifier using the accuracy, precision, recall, and F1 score, we can use here for the accuracy, we import the Adzlan metric just now library to compare the y-test and y-predictions. It's the same as the precisions, recall, and also the F1 score. And next, to append the scores value into the list just now. It may not be useful now, but it will be useful in the visualization later. And then next is to print the evaluation metrics, just to print the text to compare. So we can see here, decision tree 0.96, and 4 0.96, all until the XGBoost classifier models. And then next, to make the classifier models more understandable and more easier for that to understand, I visualize them using a bar chart, which is very, very effective for comparing models performance metrics. So the first thing I have to do, of course, import the matplotlib pyplot, because it will be easy for me to plot chart, any visualization, we need to use this one. And then take all the performance metrics form code before and plot it into variables. So yeah, in this case, I take all the classifier that I store in the list just now, and then the list in the code before, and then I use the metrics, accuracy, precision, recall, F1 score, and then I take the scores from the list also just now. And then the bar color, I set pink for the accuracy, purple precision, recall cyan, F1 score red, to make it easier for the end user to understand. And this one is just the format of the chart, and then this one is the loop to create a bar. So it will be keep repeating this code until it will reach the end model, which is the XGBoost. And then this one is just for the labels to make the graph more understandable and then more readable, of course. Here we can see here, the decision tree and Fine Forest have the same number, while Sample Vector Machine, Logistic Regressions, and K-nearest neighbor, and of course neural network have the highest amount of performance metric values, and the XGBoost has the lowest, which is 0.90. And then next, I chose support vector machines to run the classifier models because I've been using these models before, so I chose to use this model here. So of course, the first thing that we have to do before prediction model is import the important library. And next, we split the dataset into the full dataset, which is xtrain, xtest, ytrain, ytest, and we split them. In this case, I choose the 80-20 ratios. And instead, I still choose number 1. So next is the SVM classifier. Kernel, I set it to linear, and then the C is 1.0 and random stat. For the explanations, why I choose linear is basically the frequency kernel function that used for the support vector machines. I use this function because it will be easier. In this case, which means that SVM will try to find the linear decision boundary that best separates the class of the input data, which is the features data, the length, the petal, the width. And then for the C, I choose as 1.0 because it controls the regularization strength of the SVM. A higher C value allows SVM to classify more training points correctly, but potentially leading to overfitting, which is not good. But too low is also not good because it will lead to underfitting. So next, I will train the classifier, which is this one, and then I create a predictions data based on the xtest data, and then calculate the accuracy, and then also I print the classifications report and also the confusion metrics. So why I choose confusion metrics is because of multiple reasons. The first one is performance evaluations. The confusion metrics provides a comprehensive summary of the classified performance, including both correct and incorrect predictions for each class in the datasets. And the second one for the confusion metrics, why I choose it is because of the model improvement. By analyzing the confusion metrics, we can identify the pattern of misclassifications and can adjust the models using efficient engineering strategies. And also we can identify the precisions and recall class calculations, and confusion metrics also can help us with the decision making. So in this case, I use print confusion metrics and then the y-test just to print here. And then to make it more understandable for the end users, I create a visualizations for the confusion metrics for the classified models. So of course, importing the library, calculate the confusion metrics for the models, which is using the testing data and then also the predictions data. And then this one is just the format, and then I put it as blue. So as we can see here, in confusion metrics, I have a value of Setosa, Versicolor, and Virginica. So if you doesn't know, in confusion metrics, we have 4 variables, which is true positive, false positives, and true negatives and false negatives. In this case, we don't have no false positive, true negatives, and false negatives. We just have a true positives, which is the number of instances that belong to a certain class. And they will correctly classify belonging to that class by the classifier. In this case of the models, we can see here the accuracy is 100%, the precision is 100%, the recall is 100%, the F1 score is also 100%, which means that it have no false classifier. It's all true positive classifier. You can see here it predicted correctly 11 Setosa, 13 Versicolor, and 6 Virginica based on the y-test and y-prediction data, which means that it's 100% accurate. It doesn't misclassify in one variables. It's all correctly classified in this case. So this was a very important and very good models. As we can see here, the classification is all 100%, and for the confusion metric also we can find there is no false positive, true negatives, and false negatives. It's just all true positive from all along, because we can find here the value is all correctly classified. That's all from me. Thank you.